Transfer learning has become quite popular in the field of image classification and natural language processing. Here we take a pre-trained model and then we try to retrain it for the new problem. So if you remember from our data augmentation tutorial, we had flowers dataset where we are trying to classify 5 types of flowers. So in this video, we will use a mobile net pre-trained model from Google's TensorFlow Hub, and we will use that pre-trained model to classify our flowers dataset. And you will see that previously it used to take many epochs to train the complete model and achieve high accuracy. In this case, using a pre-trained model, it takes only like 2 or 5 iteration or epochs to get a superb accuracy. So using transfer learning saves a lot of computation power, because many times these pre-trained models that you can get from places like TensorFlow Hub, they are trained on millions of images. If you try to train that model on your computer, it might take days or even months. But all you're doing is you're taking that pre-trained model, you're getting all the weights and everything, and then you kind of change only the last layer or last few layers for your new problem, and then you can get a superb high accuracy with this kind of approach. So let's get started. We'll go over some theory and then we'll do coding. This is Wikipedia's definition of transfer learning, which is you focus on storing knowledge gained while solving one problem and apply it to a different but related problem. For example, if you have a model that can recognize cars, it can be used to recognize trucks as well, because the basic features, for example, the tires, the steering wheel, and some of the components between cars and trucks will be still similar. So you can use this knowledge of this visual world to transfer that knowledge into solving a different problem. In today's coding problem, what we are going to do is we will take Google's trained mobile net v2 model, which is trained on 1.4 million images and total 1000 classes. So this is a deep learning model that is trained at Google. It would have taken a long time and a lot of computational resources. You can see 1.54 million images is pretty huge data set. And the output is 1000 classes. And these classes are a little diverse. You know, you have a goldfish, shark, some animals, then some hammerhead, military uniform. So you have, it's not just the animals, it's animals and some other objects, total 1000 classes. And when this model is trained, it will have input layer, then some deep layers and hidden layers in between. Then in the end, you have a softmax layer, which is just, you know, classifying it into 1000 categories. In deep learning, what happens is we freeze all the layers except the last one. So, you know, all these layers that you see, we'll freeze it. And then we'll use this model to classify flowers, which could be one of the 5 flower types which I have shown here. And we are going to use same data set that we used in our data augmentation tutorial. So when you freeze this layer, what happens is the model weights don't change. So now when I'm performing my training, so by the way, you take the model and then you still have to perform the training. That's very important. But when you're performing a training, the weights in these frozen layers are not changing. So it almost, you know, looks like a equation. So you are having this one big nonlinear equation. So you're passing your flower and this is a training phase. And then during using these weights, you will get a feature vector. You're almost doing a feature engineering. And then you use softmax to classify into 5 classes instead of 1000. So I hope you get an idea that you're almost generating the feature vector using this frozen layers. So during the training, none of the weights, nothing changes. Okay. And omitting the last layer is a very common approach. In some approaches, they also freeze only, let's say, 3 layers or 2 layers, and remaining layers go through the usual neural network training. Okay, so we are going to now do a Python coding to use MobileNet V2 model and then use it to classify the flowers. We will download a pre-trained model from a place called TensorFlow Hub. So Google has come up with this TensorFlow Hub where you can um, get an access of different pre-trained models. So right now for text domain problems, they have all these models. For example, for embedding, they have 176 models. For image classification, they have 188 models. So these are like pre-trained models which are trained on a huge data set, which you can import and directly use it. For video also, see, they have some video and audio also, they have some problem. So if I look at image classification, here there is this model called MobileNet V2. Okay, so this is the model we are going to use. So this model, as I said, is trained on 1.4 million images and 1000 different classes, and the image is like 224 by 224. It is that dimension. So now here in my Jupyter notebook, I have imported all essential libraries. And the first thing I'm going to do is basically import that MobileNet V2 classification model. So this is how we import it. So I have imported TensorFlow Hub. Now, this doesn't come with your regular TensorFlow installation. You have to install it separately. So make sure you run pip install TensorFlow Hub. Otherwise, it will give you module not found error. Here, I am creating a classifier directly using this particular MobileNet. So if you look at, see, so you have to give this particular string, or they have a code snippet. So you just copy that. And by the way, I have used some of the code from TensorFlow official tutorial. So thanks TensorFlow, credit goes to you. But I have made it a little simpler, so I have omitted the things which are not needed. So I have done some customization. So now here the image shape, the image shape, as you saw, was 224 by 224. So you need to give 224, 224, and I'm adding the third dimension for the channel. So what happens is when you do this in NumPy, okay, let me just import it. It will just make it 224 by 224 by 3. Okay, so whenever it comes up, you see that. So that is the input shape I'm giving. And once you do that, see, you have the model ready already. So now if you want to classify among those 1000 classes, okay, so let me open the file that I have. So here in my current project directory, I have downloaded those 1000 classes, and if I open that file, these are the classes. See, total 1000 classes, and goldfish is one of the class. So I'm like, okay, let me try to classify goldfish. So I downloaded goldfish picture, and I'm going to use this model to classify that. So I have imported a pillow module and image from that. And you can just say image dot open. The file name is goldfish. This is how the image looks, but we have to resize it to 224. So I will just say resize to image shape, and I will just store it here. Okay, so it's a smaller image now, and let me try to classify this image. So now before you classify it, you have to scale it. You have seen in all our previous tutorials that before giving it for classification or training, we always scale or normalize the image. And how do you do that? Well, the color scale is 0 to 255. So you divide it by 255. So see here, I'm dividing it by 255. And when you do that, the value of goldfish, like if you look at just this array, see now these values are in between 0 and 1 range. Okay. I'm gonna do one more thing, which is, see, when you do something like this, what you're doing is you are adding one more dimension, which is one. And the reason I'm doing it is because when you do prediction, prediction accepts multiple images as an input. You cannot have like only one image as an input. So that is the only reason I'm doing it. So now I can do classifier predict like this. So now, uh, you have a total 1,000 classes. Okay, so this is making a prediction for each class, like 0 class has this probability, 1 class has this probability, and so on. So here I am going to store this in, let's say, result, and let's look at result.shape. It's 1,000. Okay, now I need to get the max. So when you do np.argmax from result, it will give you the value, the index which has a maximum value. And if you noticed previously, say it's very upfront, 0, 1, 2. See, this has a bigger value, at least in this view, 9. So that's what it is giving you. Now, how do I know which class 9 is? Well, if you look at the, just a second, if you look at our image labels, 2 classes goldfish. Okay, so it's very clear, but just to make it proper here, what I will do is I will open this file. So I will just say with open. Okay, with open what? Well, this particular file as f, and f.read will read the files, and when you do split lines, it will split the lines. And you want to store this into an array called image labels. Okay, so image label is nothing but a label array. And if you look at these labels, you will find that now you're having those 1,000 classification labels. And if you supply your predicted label index, you get a goldfish here. So this looks good so far. We used pre-trained model and we just did classification straight away. This is like, almost loading a pickled model and doing a classification. Now we want to do a classification for our flowers dataset, and you can download flowers dataset by running this command. Now we have done data augmentation tutorial on this flower dataset before in the previous video, and majority of the code is same. That's why I'm not going into too much details. But if you check this code here, all you're doing is downloading this zip file of all the flowers from Google website. This is how you download it. And if you look at data directory, the directory is dot means local directory that has data set folder that has flower photos. So if you look at our folder, see data set folder has flower photos, and that has all 5 flowers. So daisy will have daisy flowers. See, daisy will have daisy, roses will have roses flower, and so on. So let's uh, use a pathlib Python module to convert this path. This is a string path. All I'm doing is converting it into Windows path. Now, why am I doing it? Well, so that I can do functions like this. So when I have Windows path, and if I do star.jpg, it will go recursively into all the directories and get me the file path of individual images. And those paths will be needed. And if you look at image count, we have these many images, and now I am going to get all the roses images. So From data directory, I'm saying go to roses folder, and star means get me all the files. And that file path you are getting in this roses directory, roses list. Okay, let's try opening some files, So I'm using this image is a pillow library. So you can use this code to open first rose image, second rose image, and so on. See, similar thing you can do with tulips. So if I, let's say, supply tulips here, and what is this tulips? Tulips is the name of the folder. You see, tulips here is a name of the folder. And if you do that, you get all these tulips. And if you open some tulips images, tulips, so you get all these beautiful looking images. Now I'm going to make a Python dictionary so that the key of the dictionary is the flower name and the value is the list of images. So in this dictionary now, if I do roses, this will give me a file path of all rose images. Similarly, tulips gives me all tulips images. Okay, we have seen all of this in previous videos, so you should be aware. And I'm creating a label directory as well, because machine learning model doesn't understand text. So you need to say, okay, roses is 0, daisy is 1, and so on. Now, if you look at, let's say, any particular file path, it looks something like this. And this you can now read into OpenCV. So CV2 is OpenCV module, which I have imported at the top. And I'm saying IMRead, which means image read. And this thing is same as this. So I'm, let's say, reading one image. And if you look at image path, image paths are image shape, sorry. Image shapes are different. So I need to resize it because I want to, before training a model, you need to make sure all images are of same size. So here I will make image the same size. See, this is how we do it. So now I'll run a for loop on my dictionary and create X and Y. This is something again we did in the previous video. That's why I'm not going into detail. But if this code is very simple. You're going through your this particular dictionary. For each rows, you're going through each images. So going through each image is a second for loop. Then you read image one by one. Then you resize it, and you append the resized image to X, and you append the label, to Y. So if you look at X of 0, it's a 3-dimensional array of between 0 and 255. But we saw in previous videos that before doing image classification training, we have to divide it by 255 so that it can scale. See, if you do that, it will bring the value to 0 to 1. And if you want to do it on the entire data set, this is NumPy is so convenient. You can convert first into NumPy and then we'll divide it into 255. So let's do train test split first. This is a standard code we have seen in enough videos, so it doesn't need any explanation. And then we can divide these images by 255. So when I look at this thing, it's in this range, 0 to 255. Now I want to use that pre-trained model and classify some of these images. So let's say first one is a daisy. The second one is a beautiful rose. The third image is, let's say, again, it's another rose. So let's try to use our classifier to predict this model. So this classifier is what? Well, we saw previously. It is our uh, pre-trained model that we imported from TensorFlow Hub, ready-made model. And I can now predict x of 0. But this takes numpy array. So you have to give numpy array. I will give x of 0, x of 1, and x of 2. Okay. And it returned this array predicted arrays. So I will store it in predicted, and then I can do an argmax. Argmax will give you the maximum argument. And what it is saying is the first flower, this flower is 7995. This flower is 880. The third flower is 795. So what is 795? Well, we had our image labels, remember? In that, if you supply 795, it's saying this is a flower curtain. Maybe on mobile net, when Google trained it, maybe if some shower curtain had this flower pattern, that's why it is saying. Even 795, this image is also it's saying it's a flower curtain. And 880, what is 880? So what is this? Oh, this it is predicting as umbrella. So you see, you cannot here use your ready-made model, because ready-made model only has daisy as a flower. It even doesn't have all these 4 different flowers. So it's gonna make some random guess out of those 1,000 classes. 1,000 meaning all these classes. And by the way, this file and this notebook, everything is available in video description below. So make sure you download this from my GitHub. Now I'm going to retrain this model. And here I have a feature extractor model. So how is it different than the previous one? So previously, if you remember, look at it, this whole path is same. The only thing, I have classification here. Here I have feature vector. So this gives the same model as the previous one, except the last layer. So if you look at our presentation, this is the whole model, but from that model, you want to take only the layers which doesn't include the last layer. And all these layers, excluding last layer, is given by this feature vector. So you can now create a model like this. So again, I'm using TensorFlow Hub, creating Keras layer and passing this URL here. Input shape is standard shape. This is an important parameter. You are saying trainable false, which means freeze. See, freeze means do not train. So when now you perform a training, all those layers will have their fixed weights. And then I can create my model like this. So I'm putting that ready-made model and then creating the last layer, which is that the classification of 5 flowers. See? So only last layer is mine. The previous layers are already trained. And then I will run only 5 epochs, by the way. So these parameters are standard: Adam, sparse, category, cross entropy, etc. And I'm now running only 5 epochs. Now, if you remember from our data augmentation tutorial, to train the same model with CNN previously, it took us 30 epochs. In 30 epochs, we got 85% accuracy. Now check this. In second epoch, you got 85% accuracy. So you can see that deep learning training is very expensive. When you run so many trainings, so many epochs, your GPU, CPU, your electricity power is burnt. You might get a big electricity bill. But with transfer learning, you can save all that computation time. It is not just the bill. Sometimes when you're building or training a big model, it might take you days, weeks, or months. But with pre-trained model, you can retrain it for your problem so much easily. And let's look at the performance of our test dataset. That is also very good, 85%. So this is the reason why transfer learning is so popular in computer vision and natural language processing. If you're solving any computer vision or NLP problem, try to see if you can use transfer learning. If you cannot, then only try to build the model from scratch. I hope you like this video. The notebook and other links are available in the video description below, so make sure you check it. And make sure you watch all these videos in this deep learning series. I have a separate tutorial series on machine learning, Python. I'm doing Python projects as well nowadays. So if you want to learn Python or small projects, I have a complete playlist on variety of projects as well. So make sure you check it out, and thank you for watching. Goodbye.